Alright, so for this video, again, we're back on my iPad. We're going to be going over osmolarity and tonicity for this video. So first video is also on my iPad. Second video, I was able to get a whiteboard, so this one is back to my iPad. So first, we're going to define osmosis. Okay, so when we're talking about osmosis, I'm trying not to get my head in the frame. Osmosis is going to be the movement of fluid. Okay? Osmosis is the movement of fluid. This is very crucial in our body, right? Because we have lots of fluid that needs to be moved around. And so osmosis is the process and the movement of that fluid, specifically water when we're talking about this. And you might be asking, okay, well, what's the difference between osmolarity versus molarity? So osmolarity versus molarity. Okay, so osmolarity is going to be the moles of particles over a liter of solution, whereas molarity is going to be your moles of molecules over a liter of solution. In organic chemistry, Sister Sol would always emphasize that molecules are neutral. Okay, molecules are neutral. So for example, if you have 1 mole of sodium chloride, right, that is a molecule because it is neutral. But as soon as you put that sodium chloride in water, it's going to dissociate into sodium and chloride. So this is a 2-osmolar solution of sodium chloride. Okay, so you have this together, and then once it gets its charges, right, and it's dissociated, that's where you get that osmolarity. Okay, so now we're going to talk about kind of osmolarity in regards to a cell. So we're going to draw some solutions, 3 solutions. Okay, 3 solutions with water. We're going to put a cell inside of each of them. Okay, our normal body cell osmolarity is usually 300 osmolar. Okay, and I'm going to represent that by drawing 4 dots. Okay, so all of those dots, all of those cells are 300 osmolar, but the solution around it can vary, right? It can be, I'll do it in blue for the water. It can either be, we'll do definitions down here. It can be hyper, hypo, or iso. Iso is same, hypo is less, hyper is more. Okay, and so we'll first start with iso. So there's 4 particles here representing your 300 osmolar. So if we had 4 particles in the solution around it, right, that would be isoosmotic because it is the same amount of osmolarity as the cell. So that's isoosmotic. Okay, it's representing that it's also 300 osmolar. When we're talking about it, we're usually comparing the solution to the cell. So it's an isoosmotic solution, okay? I won't always write solution because oftentimes you just know that you're referring to the solution to the cell. Okay, but you can also be hyperosmotic, where you have a lot more outside, right? So this is going to be hyperosmotic. Okay, what I learned and what I remember is that water follows the party. Okay, some say water follows the dots. And when I was in 264, I learned water follows the party. So there's a lot more particles out here, right? It's a lot more concentrated. It's more than the 300 osmolar. So what's going to happen is water from inside the cell is going to leave. And it's going to go outside because it's following the party. It has major FOMO. Okay? And once it's outside the cell, it's basically doing that to try to reach an equilibrium. But what it's going to do is it's going to cause the cell to shrink. Right? The water leaves, so it like shrivels up. Okay? In another example, you could have less than what's inside the cell. This would be your hypoosmotic solution. Okay? And so now, instead, there's more cells, there's more of a party inside the cell. So water is going to go from here inside the cell to dilute it and try to get that equilibrium. So it's going to cause the cell to swell, and sometimes it can pop. That's what that's representing. Okay, and again, all of those are in reference to the solution. Okay, but then we have another thing called tonicity. So you can have something with osmolarity and tonicity. Okay, tonicity is referring to the firmness or the stretch. So essentially, Tonicity isn't referring to any actual unit. Tonicity is just what is happening to the cell when it is in a solution, right? What is happening to the cell when it's in a solution, okay? And so you can have a couple of different solutions. Remember, normal body osmolarity is 300 milliosmolar, okay? So you can have something that is 9% saline. 9% saline is the equivalent of that osmolarity, okay? These equal each other. So it's going to be isoosmotic, and it's not going to have any effect on the cell, so it's also going to be isotonic. Okay, you can also have 5% dextrose, which also equals that same osmolarity, so it's isoosmotic and it's isotonic. Okay, and then you can, oh wait, JK, please ignore me. It's not isotonic. It's isoosmotic, right? Because it's the same amount of osmolarity. But the interesting thing about dextrose is that once it's inside the cell, it will actually disappear. Once it's inside the cell, the particles will be used up in metabolism because dextrose is just another word for sugar, so it's just going to be used up. So if it's used, right, then it's going to look like this hypoosmotic, right? Because you're going to have there's going to be no particles in here, right? It moved into the cell and then was used up. So it's going to be a hypotonic solution, which will cause the cell to pop, right? It's going to go into the cell. So you can do it something where you add 9% saline plus your 5% dextrose, right? And so what that's going to do is it's hyperosmotic, right? Because you have twice the amount of osmolarity, right? You're going to have 600 osmolar, which is hyperosmotic compared to our usual 300. However, once it's inside our system, right, the dextrose will be used up in metabolism for sugar, but the saline will remain, and so that's why it will remain isotonic. Okay, so it won't be used, right? You could have examples of it being hypertonic, right, where you're going to have too much outside, so that would be like a 12% like saline solution, right? That would be hyperosmotic because it's more, and it would be hypertonic, right? Because you then have more particles outside, and so the water would go out and the cell would shrink, okay? And so those are some examples of kind of the tonicity. So if it's isotonic, nothing is happening to the cell. If it's hypotonic, that's where the cell is going to kind of start to swell, right, as in this example, okay? And then if it's hypertonic, that's where it's going to shrink, okay? But then you can also have something be hyperosmotic because it's twice the amount, but be isotonic because the dextrose is used. So that is it for osmolarity.